One of the most unsettling things about modern AI, like the large language models behind chatbots, is how confidently they can be wrong. They can generate fluent, convincing text that is completely fabricated, a phenomenon known as hallucination. This isn't just a quirky flaw, it's a major roadblock for using these powerful tools in situations where a wrong answer could have serious consequences. Here's why this is important. In high-stakes fields like healthcare, a self-driving car's navigation system, or financial forecasting, we need AI to be not just smart, but also aware of its own limitations. We need an AI that can essentially say, "I'm only 60% sure about this answer," or "This is a tricky case. A human should probably take a look." Teaching an AI this sense of self-doubt, or what researchers call uncertainty quantification, has been a massive challenge, especially for the largest, most complex models. Previous methods were often too computationally expensive, requiring so many extra moving parts that they were impractical for today's gigantic AI systems. To solve this scaling problem, researchers developed a new technique they call Scala BL. Instead of trying to teach the entire, massive AI model about uncertainty all at once, they devised a clever shortcut. Think of it like trying to understand the opinion of an entire country. Rather than polling every single citizen, which would be incredibly slow and expensive, you can create a small but carefully selected focus group. By understanding the range of opinions within that small group, you can get a very good estimate of the uncertainty across the whole population. The researchers applied a similar logic. They performed their uncertainty calculations within a tiny, simplified computational space. The real genius is in how they then translate these findings from the tiny space back to the full, complex AI model. They repurposed some of the model's existing components to act as a bridge, allowing them to apply this newfound sense of uncertainty to the AI's final output without adding a lot of heavy machinery. Let's explore what they found. This new method performed just as well as the older, more complicated state-of-the-art techniques. But the most exciting result was its incredible efficiency. Their approach required adding only about 1,000 extra parameters, a minuscule number compared to the billions of parameters in the base AI model. This efficiency allowed them to successfully apply their technique to the largest, uncertainty-aware, language model ever created, which was 4 times bigger than anything that came before it. So, what does this mean in practice? This research paves the way for more reliable and trustworthy AI. We could see medical diagnostic tools that flag ambiguous scans for a doctor's review, legal ice that highlight ambiguous clauses in a contract, or even everyday chatbots that are more likely to admit when they don't know something, rather than making up an answer. It's a critical step toward building AI that we can not only use but also truly trust. If you enjoyed this breakdown, don't forget to like, comment, and subscribe for more AI research made simple.